Hey everybody, welcome to another interesting session in this AI journey where in every single episode we cover a different algorithm or different concept which bogs you down consistently. But then in today's session, we are going to look at a new algorithm for clustering called as DBSCAN clustering, right? Now, in one of the previous episodes, we have covered k-means clustering, and now you might be wondering, like, if we have one clustering algorithm, why do we require another one? The answer is simple. It's for different kinds of applications where you require different algorithms. So let's take the whiteboard and see what's basically unique about this algorithm, right? So what is DBSCAN? Is the acronym for density-based spatial clustering for applications with noise, right? Is this clear? DBSCAN. So we studied k-means clustering in the previous video, right? So k-means was one of the centroid-based clustering algorithms. That is k-means. And DBSCAN is a density-based clustering algorithm. So what's the difference essentially? In k-means, what you do is, let's say your data which is scattered like this, right? Say, for example, like this. Now, what k-means is going to do is it's going to be creating two centroids and then trying to associate these points with the nearest centroids until the centroids move to the mean of the cluster. And then eventually, when the movement reduces to nil, it considers them as to be the final centroids and then associates all the points to those centroids. So k-means is going to be clustering these points in this way, one on this side, one on the other side. Now, suppose you have, say, a point based data, if you have a data set that's scattered like this instead. Say something like this. So like typically when you have, say, an earthquake that happens, so there's something called as the epicenter where you see the maximum shock waves, and then in the periphery you see shock waves which are less in number. So like this seems to be one category of shock waves, one cluster, and then this seems to be another category, right? So this shaded region seems to be one cluster, and then this shaded region seems to be another cluster. That's clearly observable from your visual observation as well. But what k-means is going to do in this case is that it's going to work something like this. It's going to categorize this as one cluster and then this as another cluster, because that's how k-means works. It's a centroid-based algorithm. So it's going to consider this as one centroid and this as one cluster and this as another centroid and this as another cluster. That's clearly not something that syncs with the reality here, right? And you need a different algorithm to address these kinds of problems. So these are called as density-based problems, where it actually identifies a density, and based on the density, it associates points to a cluster, right? So this is the right kind of clustering which is applicable in this kind of a problem. So how does this work basically? It starts by categorizing points into three categories. One is a core point, one is a non-core point, and one is a noise point. How do you classify a core point? A core point is one which has a certain number of points surrounded by it within a certain distance. So that distance d and the number of points n is something which the user has to specify. Let's say the distance d is, say, 5 centimeters, and the number of points n is, like, say, 4. So a core point is one which will be surrounded by at least 4 points within a distance of 5 centimeters, right? That's called as a core point. So the algorithm starts by identifying these core points. Let's say you have this point here. Is it surrounded by 4 points within a distance of 5? Yes, then it's a core point. Then it moves to the next point and checks, okay, whether is this point surrounded by 4 points within a distance of 5? Then yes, it's a core point. It goes on checking like this and creates a list of all the core points. All right, now suppose you have these many core points. All these are like core points, right? Say you have, say, 1,000 core points. And after that, it checks for the non-core points as well. Like what kind of point is this? And this is a point surrounded by only 2 points within a distance of 5 centimeters, but then not 4 points, right? So such a point is called as a non-core point. It makes a list of all the non-core points. Let's say there are 15 number, and then there are certain points called as noise points, like these points. Now, this point is neither surrounded by, is not surrounded by any point within a distance of 5 centimeters. This becomes a noise point, right? So now we have a list of all the code points, all the non-code points, and all the noise points, right? So the next thing it does is, how does it come up with the clusters? Now what it's going to do is it's going to take a list of all these code points and then just take a random code point and associate that to the first cluster. All right, let's say this is a code point, a random code point. And then what it's going to do is it's going to find out all the code points near this point and keep on expanding the cluster. Now say again, this is a core point which is within a distance of 5 centimeters from this core point, and this gets associated with this cluster. Similarly, this core point, this core point, this core point, all these core points keep on moving and expanding the cluster until we have all the core points associated to this particular cluster, right? Now, next thing it's going to do is it's going to associate all those non-core points in the vicinity of this cluster to the same cluster again. So now the next job it's going to do is, once you expand all the core points to form one cluster, it's going to be associating the non-core points as well to the same cluster. All right. So now this cluster is formed of all the core points and the non-core points in the vicinity. Obviously, noise points are not going to be included here. Noise points are going to be noise points. And the next thing is the core points over here, right, which are not close to any of the core points in this cluster. These are associated to the other cluster, obviously, right? So in this way, it has formed this cluster of these core points and non-core points, and this cluster of these core points, and obviously the non-core points in its vicinity, right? So in this way, DBSCAN has formed two clusters based on observation. And here, the number of clusters, unlike K means clustering, where you have to specify the number of clusters, like K is equal to 3 or 2. You don't have to do it here. Here, it's going to be doing it based on these metrics that you mentioned. D is equal to 5 centimeter and N is equal to 4. Based on these metrics, it's going to be segregating these points into as many clusters as it's able to form. In this case, it's able to form two clusters. So in this way, we have clearly discussed the DBSCAN algorithm. I hope this video was useful to you. If you have any questions or any suggestions, please feel free to mention in the comment box below, right? Until then, I'll see you in another episode where we are going to discuss another concept for your understanding. And then, until then, take care. Bye-bye. If you like this video, please press the like button. For more such videos, subscribe to the channel. If you have suggestions for a new topic and would want to see a video made on that topic, please feel free to comment in the comment section below. Thanks for watching the video and see you in another video. Bye bye.